So in this video, we are going to find the inverse of a function algebraically. I have a function written down that we're going to do today. The first thing we have to remember is that when I have inverse functions, so I'm going to write this over here, that if I have like a table of functions, that my inverse function takes all of the components of my ordered pair and reverses their order. So if I have something like 0, 1, and 5, 3, and I don't know, 8, 7, let's pretend like that's my function, that if I want to know what my inverse function would be, all of my components of my ordered pair would switch. So instead of being 0, 1, it'd be 1, 0. And instead of 5, 3, it would be 3, 5. And then instead of 8, 7, it would be 7, 8. And this would give me, and this is the notation for the inverse function, it would give me this flipped or reversed ordered pair. So using that logic, I can do the same thing to my function to solve it algebraically. I just have to remember that f of x is the same as writing y. So I can rewrite this as y equals 1/3 x to the third plus 1/3. And what I'm going to do is I'm going to take this x and this y, and I'm going to switch them places. So I now have the function x equals 1/3 y to the third plus 1/3. And now what I want to do is isolate my y. So I'm going to write that down and say my goal now is I want to solve my equation for the y variable after I switch the x and y places in my equation. Okay. So that's what I want to do. So this is sort of like the little verbal rules of how we do this. And so I'm going to take this x equals 1/3 y to the third and adding a third and solve for y. And the way that I do this is I'm going to put my line in here and say I've got two sides of my equation. I need to isolate that y. And the first step would be to subtract 1/3 from both sides. Or I could know that if I subtract it, it's the same as moving it to the other side and writing it in a different sign, so subtracting. And I would get x minus 1/3, and it's not there anymore, equals 1/3 y to the third. Okay. There is a multiplication right here between these this 1/3 and my y. To undo multiply, I have to divide. But when I'm dividing by a fraction, so if I divide by a third, well, that's the same as saying that I'm going to multiply by its reciprocal. So I'm going to skip this part right here and just go to the multiply by the reciprocal and say, well, I'm going to multiply by 3/1. And what I do to one side of the equation, I have to do to the other. But I have to do it to the entire side, so that's why I put it in parentheses. And those are going to reduce down to 1, and I will get that I have a y to the third on this side. But I have to distribute this through, and this is going to give me a 3x minus 3/3, which is the same as saying I have 3x minus 1, and that equals my y to the third. Okay. I'm super close. What I need to be able to do now is get that y alone, and it's got a power of 3 on it. I need to know that the inverse operation of having something to the third power is taking the third root of it. So my index and my index right here and my power right here have to match, and they are inverse operations and cancel each other out. So I'm going to take the third root of this side, a little bigger, and what I do to one side I have to do to the entire other side, and those will undo each other. They're inverse operations, and I'm going to get y alone. So now I got the cubed root of 3x minus 1, And I need to write that as if it's an inverse function. And the way that I tell my reader or my audience that that's an inverse function is instead of writing y, I say f to the negative 1. And these are equivalent when I'm talking about saying this is the inverse function. So I can write that as this, and then if I want to, if it makes me feel more comfortable to have the, the y equals first, then I can say that this is f inverse of x equals the cubed root of 3x minus 1, just like that. And that's my answer.